guppies, bubble, 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 guppy, guppy, guppy.
Within our system, there is a tomato plant whose name is coral, goldfish, and most importantly, bacteria. The plant intakes N2, nitrogen gas, and converts into ammonia, while the fish's waste and remaining food also convert into ammonia. This ammonia is then turned into nitrite and subsequently nitrate by the bacteria in the hydroton. The nitrate then fertilizes the plants and helps them grow. The plants being healthy also allow the water to keep a balanced pH and ammonia, making sure the fish stay healthy and alive. We chose this specific plant because it looks pretty and it provides food. And we chose the goldfish because we really didn't have another choice, but goldfish are pretty. The system we chose to build was a bell siphon flood and drain system. This was chosen for 3 reasons. 1, it's the easiest to follow for a beginner, making it easy to maintain and clean. 2, it can be built small enough to fit inside of a classroom. And 3, since the pump is constantly running, it allows the system to last longer.
As we first begin and then finish our system, we made sure key aspects of our system were fulfilled. Durability was ensured by measuring all the wood accurately to reduce the risk of the table being lopsided and falling over, as well as using supporting wood on the legs to ensure the table was stable at the bottom because kids bump into things and we don't want our system crashing. Our next goal was keeping it as compact as possible, and we upheld this by making sure the table's height was less than 50 inches and the width was less than 1 feet. This would allow kids to have access to the system as well being stored in a small classroom. And with our bell siphon, it can be self-efficient because it maintains a certain water level in the growth bed and the water tank. And finally, cost effectiveness. Our total cost was $161.38, and we made sure to use all the wood sparingly. And as well use it, the wood we cut and have extra, we use that in other parts of the system as well. During building our system, some challenges that we faced is making sure that we used all the spare wood in our table to make sure we were cost efficient, as well as changing measurements of the table itself, because in actuality it wouldn't make sense to make such of a big table that we had originally planned, as well as certain steps had to be improvised because, like we said, certain aspects of the table wouldn't make sense being built like that. And as well for the bell siphon, it was really just an annoying process to build and like making the holes and everything. But overall, at the end, our bell siphon worked on the first try. So all that pain and suffering worked out and our table is secure and stable. And one more problem we had is due to all the complications, we didn't have a plant log to the later end of the project. But our 2 plants are successful. So honestly, it's a win-win.
Our favorite part of the process was actually building a table from scratch, not knowing that we could do this, for one. And then our other favorite part of the process was making sure our pump and our bell siphon were working together. Being able to accomplish these 2 things helped us to move further in the building process and finally get our fish and our plants in our system. Changes we can make to our system include making our table shorter so that the system can be smaller, as well as using a smaller tote for the grow bed and a smaller fish tank so that they would be more proportionate to each other. The smaller tank will help us to reduce the amount of hydroton that we used, and the smaller fish tank would just support the smaller tote, as well as planting our plants earlier in the building process so that we will have more data for our plant log.
One of the problems we faced was our bell siphon was not working properly, and we found out that we didn't have enough holes in the middle pipe, so we took it apart and we took it out of the growth bed and added more holes, which allowed it to start draining, right? But we ran into a different problem, which was that it was draining constantly. And when we actually took it apart, there was some hydroton inside the bell siphon. So inside the small pipe, so we had to take it all apart and reassemble it, allowing it to actually like flood and drain properly. And we had another issue with our pH being too high. And one way we could solve that is through adding some of the pH down solution to lower the pH of the system in order for us to have like actual goldfish in our system, because like our pH was at 8 when we should really be around like around 7.5, 7. So okay, how to take care of our aquaponics system. So first you want to check for leaks in the system and clean the tubing and the water pump if you see any dirt or grime on it. and also have a water quality testing log that includes pH, ammonia, nitrites, and nitrates. And for a healthy pH for our system would be 6.4 to 7.4, and for nitrite it would be below 1 ppm, because anything over 5 ppm is toxic. And for our nitrates, you want it to be around like 5 ppm to like 150 ppm, and you want your ammonia levels to be ideally like below 1 ppm, or like around like 0. And right now we're gonna put up a master table with everything you need, so like any common problems or like any common like stuff that pushes it out of the normal range, and how to like possible solutions to it. And for our next thing, you want to make sure that you're feeding your fish. And for the actual growth bed itself, or like the plants, you want to prune any dead leaves on your plants, so like cut it above the node. And also you want to look out for roly-polies or any like pests on your plants, because those are not good, because they will kill your plants. And yeah, one of the most common pests, I guess, would be the like white fuzzy things building on your plants, because that is a pest that would like kill your plants. So make sure you use any like anti-pest solutions, so to make sure your plants are healthy.